Hey everyone, ready for a deep dive into some really hopeful Alzheimer's research?
Hopeful is right.
Yeah, this is pretty exciting stuff. We're looking at a new study from Washington University School of Medicine in St. Louis.
Oh, wow, St. Louis.
And it's all about prevention.
I like the sound of that already.
Yeah, and get this, they're focusing on young adults.
Yeah, adult.
Before symptoms even appear.
Wow, that's pretty wild.
Right, it's like a total paradigm shift.
It really is. Usually we're talking about treatment after the disease has taken hold,
Yeah, trying to slow down the progression.
Exactly. But this trial is looking at stopping it in its tracks.
That's incredible.
Which could have, massive implications.
Huge implications for sure. And speaking of implications, the article we're looking at today highlights this 24-year-old woman, Hannah Richardson.
Okay.
And she's part of the trial, and her family has a history of early-onset Alzheimer's.
Oh, wow.
So she's taking this really proactive approach.
I mean, that takes some serious courage.
It does. It really does. So let's talk about the science for a minute. What are they actually targeting in these young adults?
Well, they're going after something called amyloid beta plaques.
Oh, yeah, I've heard of those.
Have you?
Yeah, vaguely. I know they're bad.
They are not good. You can think of these plaques as these tiny little protein clumps
Okay.
that build up in the brain.
In the brain. Okay.
And as they accumulate, they start to interfere with how brain cells communicate. And eventually, that leads to the cognitive decline we see in Alzheimer's.
So that's what's happening. That's the process.
Yeah, that's the kind of the cascade of events that we're trying to prevent.
Gotcha. So stopping these plaques before they do too much damage, that's the key, right?
That is the key. That is the million-dollar question.
Right, but how are they doing that?
Okay, so they're using an experimental drug called remternetug.
Remternetug.
Remternetug. Now, it's important to emphasize that this is still in the trial phase.
Right, of course.
But early results have been pretty promising.
That's great.
Yeah, remternetug seems to either clear out these plaques or even prevent them from forming in the first place.
Wow, that's incredible.
Yeah, it's exciting stuff.
Remternetug, I'm guessing that name isn't on everyone's radar just yet.
Probably not, no. It's a mouthful.
It is. What's so unique about this drug?
Well, a couple of things. First off, it's administered as an injection.
Oh, okay.
Rather than an IV infusion.
Oh, that's good.
Which can be a big deal for patients.
Yeah, big time.
Think about it. Injections are generally quicker, less invasive.
Makes sense.
And might even lead to fewer side effects.
Yeah, that makes a lot of sense, especially if you're talking about long-term treatment.
Absolutely. Long-term treatment is key here.
Anything else that makes remternetug stand out?
Yeah. It also has a less frequent dosing schedule.
Oh, okay. Like how often are we talking?
So every 3 months.
Every 3 months.
As opposed to some other Alzheimer's medications that require weekly or even biweekly infusions.
That's a huge difference.
Huge difference.
So that kind of convenience could be huge.
Huge in terms of helping people stick to their treatment plan.
That's a great point. Adherence to medication is always a challenge.
Always a challenge, yeah.
So anything that makes it easier is a win.
Definitely. But this trial isn't for just anyone.
Oh, right. That's right. It focuses on people with a specific genetic mutation.
You got it.
Yeah, okay.
This trial is specifically for families who are part of the dominantly inherited Alzheimer network.
Okay.
Or DIAN for short.
Yeah, I got it.
And these families have a genetic mutation that basically guarantees they'll develop early-onset Alzheimer's.
Wow. So by studying this specific group,
yeah,
researchers are trying to learn as much as possible about how Alzheimer's develops even in its earliest stages.
Exactly. It's like having a front row seat.
A front row seat.
To the disease progression.
Wow.
Which could lead to, crucial insights that could be applied to a wider population.
Okay, that makes sense. But hold on. Didn't the trial initially plan to use a different drug?
You have a sharp eye.
I remember reading something about a switch.
You're right. They were initially going to use a drug called gantenerumab.
Gantenerumab.
Okay. But the company behind it, Roche, they stopped development because it wasn't showing great results in other trials.
Oh, so was that a setback for this trial? Did they have to go back to the drawing board?
Not necessarily. They actually pivoted to remternetug, which had already shown promise in early studies.
So it's kind of like a backup plan.
It was a bold move, for sure.
And it seems to have paid off.
It seems to have, yeah. This switch might even have put the trial ahead of schedule in some ways.
Wow, that's reassuring. But this kind of research takes a ton of resources, right?
Oh, absolutely. It's not just a few scientists in a lab.
Right. It's a massive undertaking.
It really is. This trial is a great example of what collaboration in science can achieve.
I was just going to say that. It's amazing to see all these different groups coming together.
Yeah, you've got funding from the NIH.
Okay, the NIH.
The Alzheimer's Association private foundations.
Wow.
Even a generous family.
A family?
Yeah, a family deeply affected by this disease.
Oh, wow. That's incredible.
And, of course, Eli Lilly and company who make remternetug.
Right, of course.
It really shows the power of a team effort when tackling something as complex as Alzheimer's.
It's almost inspiring.
It is inspiring.
Especially when you think about all the challenges and roadblocks Alzheimer's research has faced over the years.
Yeah, we've had some setbacks, for sure.
This feels different, though.
It does, doesn't it?
Like a real turning point.
I agree. There's a sense of momentum building.
Absolutely. And speaking of promising research, the article mentioned another study called the Diane-2 Tau Nextgen trial.
Oh yes, the Tau Nextgen trial.
Have you heard of it?
I have. It's fascinating.
It's focusing on preventing or slowing down Alzheimer's in people who are closer to showing symptoms, right?
That's right.
But it's targeting a different protein called tau.
Exactly. Tau's another key player in this whole Alzheimer's puzzle.
So we have one trial focusing on amyloid plaques in younger adults.
Yeah.
And another targeting tau in those nearing symptom onset.
It's like a two-pronged attack.
Yeah. It feels like we're closing in on Alzheimer's from all sides.
I think that's a great way to put it.
There's definitely a sense of optimism in the air.
There is, but
What? Yeah.
before we get too far ahead of ourselves,
Let's not get carried away.
let's go back to Hannah for a moment.
Okay, back to Hannah.
Her story is a powerful reminder that this research isn't just about science.
It's about real people's lives.
Exactly. And her willingness to participate in this trial speaks volume
It really does.
about the strength and hope of those affected by this disease.
It also raises some big questions, though, right?
Oh, absolutely.
Like, what does it mean to know you're at risk for Alzheimer's so early on?
Yeah, what are the ethical implications?
Those are crucial questions.
They are, and honestly, they're not easy to answer.
Not easy at all, but I think it's important to address them head on.
I agree. We can't shy away from the tough stuff.
As this type of research advances.
Exactly. So before we go down that rabbit hole,
Okay, good idea. Let's take a closer look at the specifics of this primary prevention trial.
all right, let's get into the details.
What's the actual design? What are the goals? And what are we hoping to learn?
I think that's a perfect segue
Yeah.
into part 2 of our deep dive.
Ready to keep going?
Absolutely. Let's dig in.
Okay, so let's get into the nitty-gritty of this primary prevention trial.
All right, let's do it.
It's one thing to talk about preventing amyloid plaques,
Yeah.
but how are they actually going about it? Like, what does the trial actually look like?
So they're aiming to enroll around 240 participants,
200? Okay.
all from those Diane families we talked about.
Right, Diane.
And here's where it gets really interesting.
Okay.
They're including people who did inherit the mutation and those who didn't.
Oh, so it's like a
Yeah.
built-in control group.
Exactly.
That makes sense.
Yeah, you can compare the two
Right.
and really isolate the effects of the drug.
See if it's actually the drug making a difference.
Precisely. And remember, all participants have to be much younger than typical Alzheimer's patients.
Right. Yeah, they're trying to catch it early.
Way early. We're talking at least 11 to 25 years younger than when their family history suggests they might start showing symptoms.
Wow, that's incredible. They're really trying to get ahead of the disease.
Like way ahead. It's a whole new approach.
But how do they know if the drug is working? What are they actually measuring?
Well, the main thing they're tracking is,
I'm gonna guess amyloid plaques.
you guessed it, they use brain scans to see if the drug is preventing those plaques from forming, or maybe even clearing them out if they're already there.
Okay, yeah, that makes sense. But the article also mentioned something about looking for signs in blood and cerebrospinal fluid.
Oh yeah, that's the really cool part.
Can you explain what that's all about?
Sure. So researchers are looking for specific molecules in these fluids.
Okay.
Think of them as tiny little messenger,
Messenger?
leaving clues about what's happening in the brain,
Oh, wow.
even before any noticeable symptoms show up.
That's amazing. So by analyzing these, what do you call them?
We call them molecular fingerprints
Molecular fingerprints. Okay.
because they provide this unique snapshot of what's happening in the brain.
Oh, I see.
By looking for these specific fingerprints in the blood, and cerebrospinal fluid scientists can get a more complete picture of the disease process.
So it's not just about whether or not the plaques are forming.
No, it's much more nuanced than that.
It's about understanding the whole cascade of events that lead to Alzheimer's.
Exactly. And because they're working with such young participants, they don't actually expect to see any changes in things like memory or thinking
Oh, okay.
during the 2-year treatment period.
Right, because the goal is to prevent those changes from happening
Exactly. Prevention is key here.
in the first place. But what happens after the 2 years? Do they just stop tracking the participants?
Not at all. The plan is to follow these folks for years, maybe even decades after the trial ends.
Wow, that's a long time.
It is. It's a big commitment.
It is. So they can assess the long-term effects of the drug and see if it truly delays or prevents cognitive decline.
Exactly. We need that long-term data to really understand the impact.
Makes sense. So it's a pretty major commitment from both the researchers and the participants.
It is a partnership for sure.
It also sounds like the trial has a lot of support.
Oh, yeah. Tons of support.
The article mentioned various funding sources.
Yeah, it's a real team effort.
It's pretty remarkable when you think about it.
It really highlights how many different players are coming together to try and solve this puzzle.
Yeah, you've got government agencies, nonprofits, private foundations, even a family deeply affected by this disease.
It's really inspiring.
And of course, the pharmaceutical company, all working towards a common goal.
It's amazing what we can accomplish when we all pull together.
It's really encouraging to see that level of collaboration,
Absolutely.
especially given how much frustration they've been in the past with Alzheimer's research.
I know, right? This feels different.
It does, like a real turning point.
I agree. And, keep in mind, this is just one trial among many promising avenues of research.
Oh, right. We talked about the Dian-2 Tau next-gen trial earlier.
Right, which is focusing on a different protein involved in Alzheimer's.
So we've got researchers tackling the amyloid plaques in younger folks and others going after tau in those who might be nearing the onset of the disease.
Exactly. A two-pronged attack.
It's like we're closing in on Alzheimer's from all sides.
I love that analogy, but let's be realistic for a moment.
Okay.
What happens if this trial doesn't live up to the hype?
That's a great question. I mean, we can't get ahead of ourselves.
Right, still early days.
What if remternetug isn't the breakthrough we're all hoping for?
Well, even if this particular drug doesn't turn out to be the magic bullet,
Yeah,
the knowledge gained from the trial will be invaluable.
that's true.
Science is all about learning even from setbacks.
Right.
Think of it this way. Every trial, regardless of the outcome, adds another piece to the puzzle.
Oh, even if this one doesn't work out exactly as planned, it could still pave the way for other treatments or prevention strategies down the line.
Absolutely. That's why this kind of research is so vital. It's pushing the boundaries of what we know about Alzheimer's.
And opening up new possibilities.
Exactly. And that brings us to another really important aspect of this whole conversation.
Which is?
The ethical considerations.
Right. We briefly touched on this earlier.
Yeah, but it's something we need to delve into more deeply.
Definitely identifying people at risk for Alzheimer's so early on raises a whole host of complex questions.
It does. Things like, how might this knowledge impact their lives, their choices, their mental well-being?
Yeah, it's heavy stuff. What are the implications?
Those are some heavy questions, and honestly, there are no easy answers.
No easy answers at all.
It's a conversation we need to have as a society.
For sure. Are you ready to explore that side of things?
I'm ready when you are. Let's dive in.
All right, so we've talked about the science, the trial itself, and the potential for this new drug.
It's definitely been a lot to unpack.
It has, but now we need to address the elephant in the room.
Which is...
the ethical side of all this.
Right, the big question mark.
Yeah. If you can potentially find out decades in advance that you might develop Alzheimer's.
Decades in advance.
How do you even begin to process that information?
It's a really complex issue. Imagine, finding out you have a predisposition for a disease that, as of right now, has no cure.
That's a scary thought.
It is. That knowledge could be a heavy burden to carry.
I can only imagine.
Especially for decades before any symptoms even appear.
It's like a ticking time bomb almost.
Yeah, that's a good way to put it. I mean, on the one hand, having that knowledge could allow you to make different choices in life.
Okay, different choices. How so?
Well, about your career, relationships, finances, even how you approach aging.
Oh, I see.
But on the other hand, it could also create a lot of anxiety and fear.
Yeah, I can see that happening.
And it's not just about the individual either.
Oh, right.
There are potential societal implications to consider as well.
Like what kinds of implications?
Well, think about insurance companies, for example.
Okay, insurance companies.
If they have access to this genetic information, will they use it to deny coverage or charge higher premiums to those deemed high risk?
That's a good point. That raises serious concerns about discrimination and fairness.
It does. And what about employers?
Oh, gosh, yeah. Employers could definitely use that information against someone.
Potentially, yeah. Could they discriminate against someone who's predisposed to a disease that might affect their cognitive abilities down the line, even if they're perfectly healthy now?
It seems totally possible. It's a scary thought.
It is a scary thought.
So it seems like we're entering this uncharted territory.
Yeah, like the Wild West of genetics.
Where the science is racing ahead,
but
the ethical guidelines and society safeguards might be lagging behind.
That's a great way to put it. And that's why it's crucial to have these conversations now, before this technology becomes commonplace.
I completely agree.
We need to involve ethicists, policymakers, healthcare professionals, and the public in these discussions to make sure we're using this knowledge responsibly.
And protecting individual rights.
Exactly. It's a delicate balance, isn't it?
It really is. We want to encourage scientific progress and potentially prevent suffering, but we also need to be incredibly mindful of the potential downsides and ethical implications.
It's a tightrope walk, for sure. And there are no easy answers.
Definitely not. But by acknowledging the complexities and having open and honest dialogues, we can hopefully navigate these challenges.
And harness the power of this research for good.
Well, this deep dive has definitely given me a lot to think about.
Me too.
It's been fascinating to explore the science behind this new trial, the potential benefits of early intervention, and the remarkable collaboration that's driving this research forward.
I agree. It's been a really thought-provoking discussion.
It has, but it's also clear that we can't ignore the ethical considerations. The ability to identify people at risk for Alzheimer's decades in advance brings up a whole host of questions that we as a society need to grapple with, and there are no simple solutions.
You're absolutely right. This is just the beginning of a much larger conversation, and it's one we all need to be a part of.
So to our listener out there, we hope this deep dive has provided you with a better understanding of this groundbreaking research and the complex issues that come with it. It's an exciting time for Alzheimer's research, but it's also a time for thoughtful reflection and careful consideration. Until next time, stay curious, stay informed, and keep those brains buzzing.